Consider the graph below. If the vertices of the graph are listed as V1, V2, V3, and V4, determine an adjacency matrix with respect to the above ordering of vertices and an adjacency list of G. So let's draw the matrix with the vertices as the rows and columns. So from our graph, we can see that there is a connection between V1 and V2. There are 3 connections. The edges H4, H1, and H6. So we have 3 edges between V1 and V2. Locate V1 and V2 and put 3 there. Now, since it's an undirected graph, it is symmetric in the sense that V2 and V1 also have 3 edges. Now for V1 and V3, there's only one edge, E3. So we write 1. It's V3 and V1, there's only one edge, E3. So we write 1. Between V4 and V1, there is an edge, E5. So we write 1. We do the same for V1 and V4. You can see that there are no self loops. Therefore there's no connection between V1 and V1. Write 0. So it means the main diagonal will be 0 since there's no self loops. So V2 and V2, 0. V3, 0. V4, V4, 0. For V3 and V2, there's no connection, so 0. For V2 and V3, it's also 0. V4 and V2, there's a connection, so we write 1. For V2 and V4, there's one connection, we write 1. For V4 and V3, there are 3 edges, E8, E7, and E9, so we write 3. For V3 and V4, we have 3 edges. Now our matrix is complete, so you can see it's symmetric out the main diagonal. Moving on to our adjacency list, we are only going to list the vertices with their corresponding adjacent vertices. For V1, we have it connected to V2, V3, and V4, and V2 is connected to V1 and V4. V3 is also connected to V1 and V4, and V4 is connected to V2 and V3. So this is our adjacency list.